is what I kept referring back to when we deal with what's the probability that I will do something relative to something else happening. So if it rains on Saturday and I can't go outside and I can't do anything nice, and actually this Saturday would work with that because the weather's supposed to be really nice Saturday, I will likely clean the garage. I will so likely clean the garage. I'm going to give it a 90% chance. But if the weather's nice and I can go outside and I can go do things not stuck inside, we'll call it a 50-50 chance. Maybe I'll clean the garage, maybe I won't. So what we want to answer is what's the probability that we will clean the garage on Saturday if we know that there's a 40% chance of raining. So the chance of rain relates to my probability of cleaning the garage. Question? Now, I have this solved out on your paper because I didn't want you to have to write all this down in the beginning of the lesson. But what we want to do is look at each probability. Well, if it will pop up. Apparently, I just have to let it keep playing for it to do everything. So the probability that it rains is 40% or 0.4. The probability that I clean, or the probability that it doesn't rain then, is that complement. So you always think about complementary probabilities. Probabilities always sum up to 1. You need something? So then, when I start thinking, oh, that's why it's not popping up. When I start really thinking about the probability of cleaning the garage, well, what's my probability of cleaning the garage if it rains? 90%, but it's probably not necessarily going to rain. It's only a 40% chance of rain. So I compute these combined probabilities, and I say the probability that it rains and I clean the garage, I multiply those probabilities together. My computer apparently hates me today. All right, so we take the probability of cleaning the garage and combine it with the probability of it raining. So this 0.36 is the probability that I'm going to clean the garage and it's raining. So the probability that it rains and I clean the garage together. Then I say probability that it doesn't rain and I clean the garage. Well, if it's not raining, it's only a 50% chance that I clean the garage. What's the probability of it not raining? 60%. So I take my 50% times my 60% and find out that there's a 30% chance that it's not raining and I do clean the garage. So then I add the probabilities together because both of these are cleaning the garage probabilities. I have a 36% chance that I clean the garage and it's raining. I have a 30% chance that I clean the garage and it's not raining. So combined, because I still don't know if it's going to rain or not, combined I have a 66% chance that I will clean the garage. Does that kind of make sense that we look at them together? And then because I'm looking at just cleaning the garage, I don't care if it's raining or not. I have my with rain, I have my without rain, I put them together. Questions? It's a little bit of a weird topic to first wrap your head around. So let's do a couple examples and see if we can find any questions then. Go away.
Not today.
Your computer does hate you today.
It was worse yesterday. It ran like 400 updates the other day. I hadn't updated this in a long time. All right, so here's our formula. You have this on your notes. For any two events, A and B, probability of B occurring given that A occurs, I take my combined probability and divide it by my probability of just A. A can't be 0 because we can't divide by 0. And if a probability of something is 0, that doesn't really make sense to talk about whether or not it will happen. It's not going to happen.
The probability of the
What's up with your cursor? It keeps flashing every few seconds.
It's because the smart ink, like I don't know, just it's trying to like communicate. It gets glitchy because the smart board, my smart board's a little goofed up, so it sometimes thinks I'm touching it when I'm not. Not enough to like write anything or move anything, but it's got some spots where when I draw, you can see the ink like jumps because there's some pixels, not really pixels, but there's some points on the screen, on the receiver that are goofed up. Yeah.
Things that you learn about smartphones and that.
Well, it has to do with technology too. There's 3 main types of touch screens. And this is not even a touch screen. It's a touch sensor that connects to my screen. So like cell phones, how their touch screen works has changed. You might notice new cell phones, you don't even have to touch the screen. It senses your finger when you get close, and it will click it without your finger ever making contact.
Yeah, I played to play games.
In a way, so if we ever want to play Mind Trap, I cannot get into this.
Yeah.
My buddy Christian presented a.
All the time, just like you want.
My buddy Christian presented a talk about it in college. So apparently my computer is going to be goofed up, and I'm going to sit over here for a lot of this. The first problem that we have in our notes is solved out for us, but think through this before you look at the solution. So hold up, stop looking at your paper, don't look at the solution. Think through this situation. In a study designed to test the effectiveness of a new drug, prescription drug, half of the volunteers received the drug, the other half received a placebo. What's a placebo?
Oh, I got this. A drug. It's like when they give you something, but it's not really helping, but it's just making you like think.
Anyone give more details?
That was perfect.
That wasn't actually perfect. You left out a big detail. Leah?
Like, you could have like a sugar pill or something.
Ah, it's a fake pill. So when you say give you something, you gotta, it's fake. It's totally, it does nothing. But how you said it, I could have inferred it was a different drug that just wasn't helping. So placebos are a pill that they tell you is real, but it's not. It's a sugar pill. It looks exactly like the real one. Hey Greg, can you put your phone away, bud? Looks exactly like the real one, but it does nothing, aside from give you a tiny bit of sugar. So, the probability of a volunteer receiving the drug and getting well was 45%. What is the probability of someone getting well given that he receives the drug? So we need to talk about given that they receive the drug, well, half received the drug, half received a placebo. So what's the probability that they got the drug? 50%. What's the probability that they got well?
45%.
Yeah, that's with receiving the drug. So you have this on your paper, solved out. My smartwatch just completely not working. I haven't taught from it yet.
Is that 45% of the 50% or
Yeah.
45%?
Yes. So check it out. The probability of getting well given that they are taking the new drug. That's your P of B, assuming A. So when we have probability written like this, you might want to jot this on your notes. This is probability of B assuming A. Like it is given, it is assumed, it has to happen. So our probability of getting well while receiving the drug is 45%. But if we want to talk the conditional of this probability, we're saying what's the probability of getting well when you are taking the drug? So not out of everybody. Remember yesterday when we had to go back and fix that one because when we look only at one column, it changes what my total group is. Now my total group is not everybody in the study. My total group is the half of the people that got the real drug. So that's why I then take my probability of getting well while taking the drug and put it over the group that is taking the drug. So if I'm given the pill, my probability of getting well, like the real pill, is 90%. Because think of 45% of 50%. But it's not like, it's 45 out of the 50%. So in that, if I just double it to make it 100%, I now have 90. Ben's got heads up around the face, so I'm going to draw this. I've got, if this works.
You know what's
It's not doing anything.
funny? It's the drugs that like do things that are supposed to cure something that side effects that are worse than the thing they cure.
Yeah, watch drug commercials. They're pretty interesting.
No, I found like this resume. This drug, I was watching TV. It was like, this drug may cause cancer or stroke.
It's like, yeah, I'm not gonna use that.
I saw this one that was supposed to make you go to sleep easier. The first common side effect is
Insomnia?
death. The
Oh,
second one was cancer. The third one was not being able to sleep.
Yeah, the sleep drug that may cause insomnia. What? Sorry, I'm trying to get Smarting to work, because otherwise this is hard to explain.
If you had sleeping problems, you could then like melatonin pills.
There we might go. All right. It's not going to be captured in the video. Hey, give me your attention real quick. It's not going to be captured in the video, but I think we're all here today. Here's my group of 100%. Here's who got the drug and who got the placebo. Now, do we know anything about the placebo group beyond that they got the placebo? No. But what I know about the group that got the drug is of that group, 45% of the total people in the study got better and had the drug. I don't know how many people got better from the placebo, but I don't care. I know that 45% of the total group got better. So if I look at just those getting the drug, this 45% now actually turns into 90% of the drug group. Does that make more sense now?
Yeah.
Okay. It's visual. That's why I kept trying to draw the picture. All right. So try to got it. Check this situation out. In a study designed to test the effectiveness of a new drug, half the volunteers received the drug, half got the placebo. The probability of a volunteer receiving the placebo and having his or her health improve was 20%. So those people who got the fake pill, 20% of the group, like 20% of the total group, got better when they had the placebo. What is the conditional probability of a volunteer's health improving given that they receive the placebo? Ben? 40%. 40%, because now my placebo group, this unknown, my people that got better receiving the placebo, now I know that's 20% of everybody. So when I look only at the placebo group, that now actually doubles because my 50% becomes my 100% and turns into 40% of those people.
So people got better just from sugar?
They felt better. They thought they were going to get better. And your brain, what you think, your attitude can do a lot. There's actually...
Because they probably didn't tell them that they...
Oh yeah, you never tell somebody that they're getting the placebo. Otherwise you would ruin your study. So like somebody could give you, like they could invite you in for a drug study and say, this pill will make you focus 10 times better than without the pill. So you wake up in the morning, you take the pill and you're like, man, this pill's going to make me focus really well. So you go into the day thinking, oh, I'm going to focus really well today because I took the pill. Even if the pill's fake, you have the attitude of, I'm going to focus really well today because I took the pill.
Well, what if you keep on thinking about the pill, even when the teacher's
You're
telling you?
focusing on the pill.
In 6th grade, our science teacher was like, every 6th grade student will participate in the science fair. So I had to. And me and my friend Ellie, we did a test on that thing.
Yeah.
Yeah.
Placebo effect. What'd you guys find out?
That people generally did a lot better if they thought that they were smarter.
Yeah. Like that. You guys heard about the genius drug? Like the, what show has the Limitless? You heard about that show? So supposedly it's a real drug now. Like it's a real pill that you can get that makes you like 10 times smarter and like 100 times more effective or something like that.
Well, that makes
And now they're
sense.
banning it in certain states. But who knows if that's even real? You could sell people a drug and just say it does X, Y, Z, and it could actually do nothing. All right, moving on to number 2. Now you need to fill in the unknown parts. So now we're surveying about pets. In a survey of pet owners, 45% of the total group own dogs, or a dog at least. 27% of the total group own a cat. Oh wait, it's important. 12% own both a dog and a cat. So what is the conditional probability that a dog owner also owns a cat? So when we set that up, we're saying, what is the probability that you own a cat, assuming that you own a dog? So try to set that formula up. What's the probability that you own a cat, assuming that you own a dog? So now my total group is those who own dogs. So I've got 45% of people own only a dog, 12% of people own a dog and a cat. So how many percent of this group in total own a dog? That's the first thing you want to think about. So you want to take that probability of both happening divided by the probability of just A happening. You can move on and try the second problem. What's the probability of somebody owning a dog assuming that they own a cat? I'm really upset about my smartboard now. I don't think you guys understand this. Like, this makes me worried because if I can't, I might have to run some smartboard updates.
Mr. Hudson, do you know why we write the numbers the way that we do?
Yeah, there's a whole video about that.
The way that we were originally supposed to be written.
How many lines?
Really? I thought.
Well, okay, so there's a couple theories behind it. It started with how many, like, I forget it was lines or points it takes to make the number. So, like, 1 is 1 line, 2 is 2 lines, 3 is, like, 1, 2, 3. Those have the points. 4 is 1, 2, 3, 4.
I was reading about it and it was with angles and like none of them had like curved lines unless it was 0.
Okay.
Lines. Like 2 was like that angles there.
Right.
I have a
What do you think? Yeah. Question?
Yeah. I was gonna ask if I did this right.
I'm just gonna show it since it's not letting me write today. So we take the probability of both, which is my 12%, over the probability that they own a dog. And this is worded kind of poorly. What we can see now is that this group of 45% doesn't work today. That group of 45% owns a dog but might own other animals because all my denominator is that they own a dog. So we know that 45% of the people surveyed own a dog. So those 12% that own a dog and a cat, those are contained within that 45%. So when I look at actually what's the probability that a dog owner has a cat is only 26%, almost 27%.
How are they different?
What do you mean, how are they different?
Because if you own a dog, if you're a dog owner and you own a cat, then you're a cat owner and a dog owner.
Okay, so I'm glad you asked that. This first situation is assuming that you own a dog. The second situation is assuming that you own a cat. What's the probability that you have a dog? Situation 1 is assuming you own a dog. What's the probability of having a cat also? The second situation is assuming you own a cat. What's the probability of also having a dog? So you can see is when I own a dog, I'm not very likely to own a cat. But when I own a cat already, I'm more likely to also have a dog. Questions on this? This is where the order of what's assumed and what's conditional really comes into effect. That's why I'm trying to work through this kind of slowly. Questions?
What's the difference between assumed and conditional?
So the assumed is like given that this has to happen, given that it's raining, given that I own a cat. Then the conditional is that I clean the garage, or that I also own a dog, or also own a cat, or one of those also situations. That makes sense? So try that, got it. Try to put this in to the right situation. What is the conditional probability that a pet owner owns a cat and some other type of pet, given that they own a dog? So your assumed probability here, that given occurrence that will be in your denominator, is that they own a dog. I'm going to go back and capture these other pages. So give me just a second, then we'll take this answer. What if I click on the pen if it will let me do it?
I'm sorry, I just did the question.
Come on.
Wait, Mr. Host, is it hooked up to the computer? Because
Yeah.
the smartboard works when you press the
Yeah,
button.
it's. I mean, the fact that it's picking up my fingers, it's hooked up. I think when I ran my computer updates, now my smartboard has to be updated to get with my computer. That's why I normally don't update this computer, but it did it on its own. Like it didn't ask me. It forced it. So I'm gonna again work on the chalkboard just for a second before I show it.
I hate the chocolate.
What is it that we're assuming here? What's our given, Robert? That we own a dog. So in my probability, that comes second. What is what I'm asking? What is the conditional? Well, it says, what is the probability? Oh, come on, go away.
Did you mean to do that? What's that?
All right, well, now my computer's, there we go. What is the conditional probability that a pet owner owns a cat and some other type of pet? So, this would be cat and. Cat and some other type of pet. My given is that they own a dog. So, my probability of owning a dog, that's what would go in the denominator. In the numerator is the probability of both happening. Wow, this is, like, it's gotten worse.
I wanted to stay.
Hey, there's some blue.
Wait. Try and write some more.
It still thinks I'm on blue.
We'll draw.
All right.
That was very good. It was beautiful if it had music that covered it.
So, notice the probability that they own both a dog and a cat, and 5% of pet owners own a dog, a cat, and some other type of pet. So this is my, ooh, here we go. This is my and. I just had to kill it and open it again, I guess. So that goes on top. And my probability of just owning a dog, which they could own a dog and a cat, or a dog and a cat and elsewhere. Hey, look, 7th grade grades. So my probability of a dog goes on bottom. Digits updated, and now I have to run Excel files every time I need to check grades. It's really annoying. Questions on how we got this are 11%. If you do not understand what you're doing, please ask a question.
I have no idea.
Well, that's because you've been looking at the back of the room every time I look back there. What is your question? Every time I try to look back there, you've been like blatantly trying to not look up here. So what is your question? Because I think you're just not engaging in the lesson.
The cat, and then you put the plus, and then the line, and then you put the dog thing. I don't get that.
That's not. That's and. So as I said about 3 times when I wrote it down, that's and. So we have to write our conditional probabilities by first setting up what am I looking for, and then I use that bar to separate from what am I assuming, what is given, what has to happen. So we set up what's the probability that they are going to own a cat and other animals. So that's why I say cat and conditional to the fact that they have to own a dog.
Wait, so the right is like a given.
Yes, exactly. And that, the value that's on the right that you just said there, that's what ends up in my denominator. But my numerator is both, is the fact that both have happened. So that's when I look at 5% of pet owners own a dog, a cat, and at least one other type of animal. So that's where I get my 5% that goes on top. But because it's 5%, and I now am comparing to the total group, this is still, guys, part divided by whole. Every percent, every probability that we do is still always part divided by whole. But now my whole is only the amount of the group that own dogs, which is 45%. My part is the part of the group that owns cats, dogs, and other animals, which is 5%. So I take 5% out of 45%, find out that's really about 11% of the dog owners.
Jocelyn, Elder, and Melissa, you to the office, please.
Wait, would you want us to write 1
You could, but this is real. So guys, understand this is the statement we're saying. 11% of the people that own dogs also own a cat and some other kind of animal. This is of the people who own dogs, because this secondary has to happen. That is now the group that I'm looking at. So if we move on and look at, is it going to capture now? If we look at problem 3, we can go over a couple of the homework problems together if it's still giving you an issue, like whether we do it today or whether we do it Monday. All right, so now we're going to use tree diagrams. And tree diagrams take our situation that occurs and breaks it up so we can visually see. The one issue that I have with tree diagrams is it doesn't do a very good job of sizing. I like to, like, when I drew that visual over there, I sized my percentages according to, like, based off 100%. Tree diagrams don't necessarily do that. So if I make a tree diagram to say 70% of freshmen attended a public school, this is college data. Like, so from a university, they found that 70% were public school. So 30% would have been not public school, so maybe private, maybe charter, maybe something else. So when I start drawing that tree diagram, and this solution's on your notes, I'm just going to show it to you, 70% go to public, 30% go to other. Then, of the public school kids, what do we know? 60% of freshmen who had attended public schools graduated within 5 years. So 60% graduate. The other, the complement, don't graduate. So where this is really nice is if I asked you, what's the probability that someone who had attended a public school, went to this college, and did not graduate within 5 years? It's not 40%. It's 40% of the 70% that already happened. Because this 70% is needed, and this 40% is needed to get out to here. So what would I do with my 70% and my 40%? Multiply them together. So my percent then is going to be less, because obviously that's a small portion of the group. It's 40% of the 70.
It's 28%.
Is it?
Yeah.
So we can say 28% of those freshmen that attended public schools did not graduate within the allotted time. Now, if I ask you a contrary question, how many people that had attended not public schools, so charters or whatever else, how many of those people, like what percent of the total freshman class, did not graduate who attended not public schools? So again, I start with freshman class, I go to not public schools, did not graduate. What would that give me?
6%.
Yeah, 6%. 2/10 times 3/10. So, of those who attended, we'll just say private schools, of those who attended private schools and went to this college, only 6% of that group, or only 6% of the total class did not graduate those people were those who did not, or those who did not attend public school. So tree diagrams are nice to visualize our percentages.
One more time, Robert.
So here's some examples that they show out. Probability of graduating just in general. So the third one here is interesting to look at, and you guys want to fill these in. By the way, they're on your paper. You want to fill these in.
Okay.
I'm looking around and some of you are not on the same page as me. So they start on the right side and work left. I start on the left side and work right, but because multiplication is commutative, it doesn't matter. But the third one down here, what's the probability that they graduate? Well, I have two different groups that graduate. I have this group that graduates, I have this group that graduates, and this group that graduates, but if I add those together, I'm going to get 1.4, which would be dumb, because probabilities are all out of 1. So really to talk about this group, that's 80% of the 30%, which gives me 24%. And this group is 30 or 60% of the 70%, which gives me the 42%. I combine those values to add up all those that graduated. Does the tree diagram make sense?
Yeah.
I like tree diagrams because if you are struggling with conditional probability, make a tree diagram. It will help you see what you're doing. So, soccer team wins 65% of its games on Friday on muddy fields and 30% of their games on dry fields. The probability of the field being muddy for the next game is 70%. What's the probability that the team will win their game? What's the first split that I would actually do in my tree diagram? Greg?
Would you have 3 splits?
What do you think they are?
It's muddy field, win, and then like win on the dry field, and then it's losses.
So really, the two differentiations there that I heard you say were win-losses and muddy-dry, right? So I don't want to start with win-loss. I want to start, what's my first split? With muddy-dry. So I start with what's my probability of muddy? What's my probability of dry?
65 to 30.
Well, that's...
70 and 30.
Yeah, we got to look at this. The probability of the field being muddy for their next game is 70%. So this is a 70% or a 0.7, and this is a 30% or a 0.3. Then we split and say win, lose, win, lose. Now the question is, what percents go with that? So be very careful when you read this. Soccer team wins 65% of its games on muddy fields. So, win on muddy fields is 65%. Which means that the losses on muddy fields would be 35%. The wins on dry fields, 30%. So this team apparently plays a lot better on a muddy field than on a dry field.
Maybe they can mud into the enemy's eyes.
Well, there you go. Maybe the team's not very good, but other teams get worse in the mud, or however we talk about this.
They don't.
So to clean it up a little bit, there's what this would look like. And my percentages, I did not really have a good place to put them. So I've said this. Really, we want the percent to be on the way to our descriptor. So we say there is a 70% chance of a muddy field. So when I read left to right, like I really put my percentages when I drew it in a bad place because I was crowded. But you want this to read left to right. So there's a 70% of the field being muddy, and if it's muddy, there's a 65% chance that we win. But to figure out what's the probability of, what's the question we asked you here? The team winning their next game, well, I need to look at both win situations. So I've got my first win situation, muddy, win. So 0.7 times 0.65?
45.5%.
What is it?
45.
Oh, you're giving me the answer. That's So when given muddy fields, this multiplication.
Yeah.
Oh, yeah. So I didn't realize there's more below. Well, I thought you were jumping ahead of me
No.
because I didn't do this multiplication yet. So that's 0.445. Then I look at when on the dry field. What is that? 9%. So then if I add these together, yeah, we'll get 54.5%. Scroll down so you can see all that. You look like you had a question. You good? Okay.
We're not done though, are we?
We're almost gonna have to be done.
No. Can you go back?
It's up there, dude.
What? That's not it, is it?
Yeah, that was the answer to our question. What's the probability they win the next game? I don't know if it's going to be muddy or dry. So I take each win situation. So I've got the probability of winning if it's muddy, and we don't know, like, not the probability of winning when it's muddy, but the probability of winning if it's muddy.
But then, like, on the first one, you have to also...
Watch yourself, shortstop.
I have to also what?
Like,
Here, I'll go
on
back.
The first one we did. Like, the very first thing.
So, what we have to look at... Hey, guys, stop talking. I'm trying to explain something to a classmate of yours that doesn't understand it, and it's really rude that you don't care. So the first thing we look at is what's the probability of winning if it's muddy. So I have to take, I don't know if it's going to be muddy, but if it is, we have a 65% chance. So this is the probability that we win, not knowing if it's going to be muddy. And then I also have to look at what's the probability that we win if it's dry. So that's where I get, this is my like 45%, and this is my like 9%, because there's a 9% chance that we will win if it's dry, like it's putting them together. It's saying if it's dry that we will win, or if it's muddy that we will win, and then I combine them to say what's the probability that I win.
So, like, on the first page, we had to multiply, like, or the garage.
Yeah, these are two different skill sets.
Could I please have Olivia Judy to the office? Olivia?
There's only 13 questions, so try these out, and please bring me your questions about this homework. I want to start on Monday. Stop talking at the same time as me. I want to start Monday by taking any questions from any of these homeworks. So please bring all your homeworks to class and any questions that you have on any of them. Understood? That's what I just said. We're going to start by doing, like, yeah.
Olivia, I told you not to let it go, bud.
Thank you guys. Have a good weekend.
Have a good weekend.
Olivia, you're all
I think only 7. I think we only have one more to go.
Oh, really?
Yeah.
It's me.
I can find out real quick.
Ask Leah. She'll tell you I'm so ready to be.
Yeah, there's only 7.
You're the person.
we're supposed to be inside. I just want to be unusual. I just want to be unusual.
We get to do emotional, but then also spelling to sweat.
Probably the 8th graders that were just in here because those boys smell. They do. Like that's. But I think the lotion came in with you. Yeah, I think it's Cassidy. All right. First things first. I am the realist. Now, first things first is next week on Friday we will be taking a survey for Dominican University. So, if you know Carrie Marzita, her father is a professor at the ODU, and he has a student doing a senior honors psychology thesis. A thesis is like a really big paper that you write. Come on, you won't be able to go back there. Actually, you're gonna have to work on Chromebook, so you can't actually do that there. But we're finishing the test. So you gotta finish the homework first. So this form does not need to come back. Hear me when I say this. This form needs to make it into your parents' hands or on your fridge or wherever you put important things. But everyone look at the bottom. Notice it says, I do not wish for my child to participate. This is an opt-out form. If I get one of these back signed by your parents, that means you're not taking the survey. Some parents are like uncomfortable about that sort of stuff. I don't know what questions are going to be asked, but they're just general like school questions, like the surveys that you've taken before about school. So if you bring this back, that is to not take the survey. But if you don't take the survey, you'll just be sitting there like doing nothing. So you should take the survey. They want good data. And anytime that we can participate in surveys, like us as Phoenix, we don't really like to talk about this very much, but our program is not necessarily permanent. We don't know how long we will get to stick around. Worthington could any time they want say, hey Phoenix, this is your last year. And they could replace us with something else or a traditional school or whatever. So the more data that we have to share, like how our differences between our school and other schools help students and like, you know, how that student voice, student choice, how that all plays into things, that helps us to be able to say, here, look at this data that we've got. Because instead of us just saying, oh, our students love our school, we can present data and results and say, look at this, we need to keep operating, we need to stay how we are. So, not that we're worried about that ever happening. We're a pretty awesome school for the district to have and be able to like brag about. It's kind of like Linworth. They kind of brag about Linworth a lot. So don't worry about that happening, but don't think like, oh, I'm going to opt out of the survey so I don't have to do it. No, we want you to do it, please. It's, hey Eli, I'm talking, so if you could not, I'd appreciate that. Thanks. Please explain to your parents that, the paper goes over what it is. Well, explain that it's just another survey so we can collect data and compare our school to other schools. Cool? Clip that in your binder. I would put it in your to-do list. There is no new homework today. Now, a lot of you, when I printed the grade report this morning, still need to finish 11.5, but that's okay because I just posted it yesterday. So if you are like multiple assignments behind that one, I might call you up and chat with you really quick about what your plan is, how you're feeling. But I'm going to pass back pretty much everybody's tests. Our goal is to have these done today. If you need a ruler still, they're up there. If you need a ruler, number 5.
Wait, is it not open note anymore?
No, not now. It was only open note because I kind of blindsided you guys with the test. You like weren't really anticipating it. And now we've had another day of practice and another day that you should be more comfortable.
Can we use the calculator?
Yes, you can use calculator. What's up?
Are we going to have a chance to
I don't know. I would like to not need to do that, but it depends on how people are looking. Because between 2 class days, that should have been enough to get through the test. I mean, that's like almost an hour and a half. Your notes back, right? For some reason, the sub collected the notes. Yeah. And then we finished 11.5 yesterday, so the video's up on School Gene Social Media. Watch out for your headphones. So guys, tests are out now, so you should not be talking. We're having big issues with like some minor behavioral things, which just get really annoying when they're, it's like, not like anyone's trying to start fights or like bringing weapons, but the minor behavioral issues start to get really annoying. So the fact that like when we stop talking, you immediately start talking, that's really frustrating because we waste a lot of time trying to recenter and get your attention back. But especially when tests are out, we don't want to assume that you're cheating.
What if we already know we need
Work on anything for school. Isaiah never showed up today.
No.
He's in North Carolina.
Oh, okay.
Yeah, that's North Carolina.
Yeah, I have one up here.
You're welcome.
Thanks. You gonna get your homework done over the weekend?
Yeah, I was gonna play Close on the
Same here.
Yeah, that's not big to see, especially since we only covered one of those lessons this week. So you should have really had these done, right? So come on, don't keep doing this to yourself. The test is going to be harder because you haven't practiced this. So do whatever you can on the test, skip what you really can't do. You get a crumb. Yeah, on the open-ended questions, like the not multiple choice ones, you can use 3.14 or you can use exact pi. I know there's a range of answers that I'm looking for, so whichever version of pi you decide to use, that's up to you.
So would that work? Would that
Um,
be that on a lot?
Yeah, that's fine. You can leave it in terms of pi there.
Wait, which question? Like the
I don't know what in progress means, but you probably getting stuff done. Yeah.
Is the video listed of your
Schoology. Yeah, it should be right there where you're always used to getting to it.
all the sides the same on the 23?
Are all the what?
Like, sides, same length.
Yes.
Okay, I just
And
wanted
you could also figure that out, like, yeah, because it only says has dimensions of 20 yards. That tells you that's the dimensions are the length and the width and the height. Like those are dimensions.
Yeah.
So since it only gives you a dimension, they are the same.
Okay.
Good question,
And-
because it does say rectangle.
Yeah.
On 23, it's a square. It says rectangular, but a square is a rectangle. So the fact that it only gives you 20 as the only dimension means the length and the width have to be the same. So wait, why are you? So when you did this, what were you finding the area for with this?
The circle. Well, one circle.
One circle, right?
Yeah, and then I multiplied by 2.
Are both circles the same size?
No. Okay, thank you.
Does that help?
Yeah.
You're welcome. People aren't where.
Is that what you told your mom? So have you done all your math homework? No.
Yeah. He actually, I was just saying, he came and talked to me. I think it was just yesterday. It was either yesterday or Wednesday. Apologized for his, because I've been like riding him for a long time about this stuff. He apologized about his lack of effort and like work completion or whatever. And said he met with his dad and they had a plan to get caught up and whatnot. But
Oh, I told him.
so I'm sure he's still not telling the truth when he talks to dad about that. Yeah. You can get a crumble. Yeah. So guys, a helicopter's rotor, it's a straight line, but when it spins, it makes a circle. So yeah, and a rotor is also a part of a car's brakes. It's what the brakes grip onto to slow the car down. Yep. As long as you're not taking your test.
I don't get what this says.
Which?
The minute hand of the clock is 16 centimeters long. And that it needs, it's asking me how long it travels in 20 minutes.
So, person, hey, you have something on your nose. You got it. So, if the clock, let's just start. These back ones are kind of exemplary. Well, I mean, they're not really exemplary often, but they're kind of like challenge problems. So, if I have a clock, bad clock, but I start here and I go 20 minutes. That would not be enough to be 20. 20 would be like here. So, 20 minutes is how much of the circle? What portion of that circle?
It's a third of the circle.
It's a third of the circle. So you're going to have a third of the circumference, which the hand length is actually the radius. So you figure out what the circumference is, find out what a third of it is.
Okay.